So in each of these three test tubes, A, B, and C, we have an initial violet color of the cobalt chloride solution. In test tube A, we're going to add calcium chloride. In test tube B, we'll add hydrochloric acid. And in test tube C, we will add silver nitrate. So in test tube A, I'm going to take these in there and we're going to look for a color change. So we have it in there. And we can swirl that around. And those little balls are becoming blue as the cobalt chloride is reacting with them. You can see the balls of calcium chloride starting to turn blue. What? No, let's just start.
Okay.
Can I go get a stirring rod? Aha! So it's nice and stirred up. It's still kind of blue. Okay. Now we're going to add one more piece and see what else happens. Okay, so that's very blue now if you compare it to the initial purple color that we have. And this is the one with the calcium chloride in it. So it's clearly much more blue than our initial solution.
What is happening here is as the calcium chloride dissolves, it sends calcium and chloride ions into the solution. The calcium doesn't do anything because calcium doesn't have any part in the reaction. But the chloride ions are used up as a reactant in the production of the cobalt tetrachloride ion. So that chloride is used up and it shifts the reaction that way, producing that bluer color due to more cobalt tetrachloride.
So we're going to let that reaction go. Now in test tube B, we're going to add a few drops of hydrochloric acid. So you can see its initial purple color here. And then as we add some drops to it, and that solution is much lighter than the initial solution. So this is the one with hydrochloric acid in it, test tube B, and it looks much clearer than the initial one.
Hydrochloric acid is HCl dissolved in water. HCl dissociates completely into hydrogen ions and chloride ions. So adding it, it will shift the reaction towards the right being the side of the cobalt tetrachloride ion. So that's why you see the bluer color here.
And so finally, in test tube C, we are going to add 1 milliliter of silver nitrate in here and watch for a color change. And that turned completely white. It's a little bit pink, but it looks white. It's cloudy. You can compare this to our initial, this color that has the calcium chloride in it.
So what's happening here is an odd case. It's not just an interaction between ions in the solution. This is it's a direct reaction that forms a precipitate. So you'll see with the addition of the silver nitrate, it will form that white precipitate. That is silver chloride. The silver nitrate is going in and it's latching onto that chloride and it's pulling it out of solution. So there's no more of the chloride left in the solution. So taking away that reactant, it will shift it to the left, to the side of the cobalt hydrate. So you'll see no blue color, and you'll see that red color, and you'll see that white precipitate all throughout. So much so that you can barely even see the reddish pinkish color in the video, but it was there.
So now here we have a cold bath, and a hot bath. And we have split up our reactions from the first part of the video into a hot and a cold one. So this is a cold and this is a hot. So the cold one is going to go into the cold beaker and the hot one will go into the hot beaker. And now we are going to wait for a minute to see any color changes. Okay, so after a few minutes of watching these two change, this one from the hot beaker is clearly much deeper blue, more of a royal blue now after sitting in the hot water. And as we pull the cold water out, you can see it's very light. It's almost a turquoise. So you can see there's a big color change between the hot and between the cold.
So using the chilled or heated water baths here, it reveals something about the reaction. If you take a look at the heated bath, you can see that it's a much richer blue color and much clearer, versus on the right in the cooled bath, you can see it's still blue, but it's such a lighter blue and it's not as strong. So this reveals that this reaction is endothermic in the formation of cobalt tetrachloride. Now, here, there is such a superfluous amount of the calcium chloride in solution that it's really hard for it to go back to that hydrate form of cobalt that's red, but it still is revealed to be occurring here with the reduction in color from the left to the right one.
So now we are going to look at our B test tubes. So this one will go into the hot beaker, this one will go in the cold beaker. They're both this light pink, and we'll see how the color changes. Okay, so after about a minute of letting these sit in their baths, the cold one, the pink color is clearly much darker. So it's a much darker, richer pink that we can see there. And the one in the hot bath did something very interesting. You can see that it is now blue. So the pink color disappeared after about 5 seconds. It turned clear. It was clear for maybe 20 seconds, and then it started to turn a dark blue again.
So as you can see here, the HCl with the cobalt chloride, it is this red color, this pink color, instead of what it originally was when we first added the HCl, which was this bluish color. This is due to our own impatience and wanting it to display a stronger color reaction, to display a stronger blue. What I didn't expect to happen was for it to instead go this pinkish color. Why this happened was because the chloride stopped being potent, adding so much of it, but the water started to become more prevalent a factor as the water became more and more of a percentage of the solvent mixing with the ethanol, or I don't know what's ethanol, the alcohol. So this started to form the hydrate ion of the cobalt more prevalently than the cobalt tetrachloride, so the red color is obviously more prevalent here. But so anyway, what's happening with the heating and cooling is, since it's such a close ratio of the chloride and the water, this allows it to very easily switch between the colors with heating or cooling. So the heating, you can see this endothermic much more clearly with it turning to blue from the pink, and then you can't see it very much because of the weak saturation of the pink in terms of color, but it does turn more strongly pink.
Alright, now we have our test tube C. We have test tube C hot and test tube C cold that we are going to place into their baths. And test tube C is holding the silver nitrate. Okay, so after about a minute of watching these, we can pull both of these test tubes out and see that the color has not changed at all in either of them. So there's still that light pink in the silver nitrate C test tube.
So as you can see, This solution did not change color in the heating or cooling bath. It stayed the same white, cloudy pink. This is because, as I talked about previously, all the chloride was pulled out whenever we added that silver nitrate. There's no chloride left in the solution. This means that all you have in there is cobalt hydrate. You cannot form cobalt tetrachloride, and there is no cobalt tetrachloride. This means that whether you heat it or cool it, you cannot reverse the reaction at all. You cannot push the reaction forward at all. There is a complete lacking of one of the reactants. So, this means that you cannot form more of the cobalt hydrate because there's not that reactant of the cobalt tetrachloride. And you cannot form more of that cobalt tetrachloride because you have no chloride. So, it's going to stay that same color whether you heat it or cool it. You need to add more chloride if you want to see a change in the color at all. You need more reactants than just the heat.